AP Statistics, Unit 3. This is multiple choice Form C answers. So it says staff members of a high school newspaper want to obtain an estimate average number of years of teachers that have been teaching. So an educational conference attended by many teachers in the state, the staff members randomly selected 50 conference attendees, that's important, and asked the attendees how long they have been teaching. Which of the following describes the sample and the population to which it would be most reasonable? Well, remember, the sample comes directly from the population. The sample has to be completely contained in the population. So here's the population, right? And the sample has to be within it. So you have lots and lots and lots and lots of samples within the population. But it tells you right here that I highlighted, that's my sample. And then the population would be all of the conference attendees, which is letter B. Number 2, publishers of a magazine wish to determine what proportion of the magazine's 50,000 subscribers are pleased. So this is what I'm trying to determine, are pleased with the subscription. The publishers intend to mail a survey to 1,000 subscribers randomly selected to those who have received the magazine for 5 or more years. So it's only going to those that have received it for 5 or more years. But it tells you this is selection bias. And since long subscribing customers are more likely to be pleased with the subscription. So which following will eliminate the selection bias? So letter C, the reason letter C is correct is because if I send them to all the subscribers, then I won't be just giving it to the ones that are probably most pleased because they've been long subscribers. So those that have had it a month, all the way to those that have had it for 20 years or whatever, the whole thing. And that's going to be the selection. This is 5 or more years, 1 year or less. This would be a problem also because you want everything. This is the only one that says all. So I'm just kind of looking through them and trying to make sure that there's not another problem, but this is the best one for sure. Some contact lens wearers report problems with dryness in their eyes. So that's dryness in their eyes. It sounds like it was what they wanted to study. A study was conducted to evaluate the effectiveness. So here's the effectiveness of the new eye drop to relieve dryness of contact lens wearers. So I have 25 volunteers. That's important. It's volunteers, not randomly sampled. And that's okay. We just have a different conclusion. Who wore contact lenses agreed to use the new solution for 1 month. At the end of the month, 36% of the volunteers reported that the new solution was effective in relieving dryness. The company that produced the new eye drop solution concluded, here's the conclusion, that using a new solution is more effective in relieving dryness than using no solution. Which of the following explains why the study does not support the conclusion? Well, yeah, it's not too small. It's fine. And we don't even, I don't think we see that we have 25 volunteers. That's not the problem. But the biggest problem is I have nothing to compare it to. That's then, which means it's a control group. Volunteers is okay. As I said, that volunteers means that I just can't, I only can do it to my group. I can't do a bigger, I can't generalize to the population. But and then self-reported frequencies. No, we're going to need self-reported. That's okay, because otherwise I don't know what they're feeling. So that's going to happen. It's self-selection is the problem. If you're selecting, oh, I get the eye drops or I don't, or I get the placebo or I don't. But there was no placebo, and that's the problem, is that if I don't have something to compare to, I can't say, this is basically cause, that I can't say that I have a new or more effective than one or the other. Okay, number 4, a paint manufacturer conducted an experiment to investigate whether a new formula produces paint that lasts longer than the exterior of the building than paint produced from the older formula. So new versus old. So a grid of 20 squares was drawn on the exterior of wall of a building. The new formula was randomly assigned, randomly assigned to 10 squares, and the older was randomly to the other 10 squares. Each square was painted by the assigned formula. 1 year later, each square was rated on how well the paint lasted using a numerical scale, which was larger for indicated the lasting paint. Which of the following best describes the experiment? Okay, so I am literally doing this. I have 20 squares, and I'm going to randomly assign them to group 1, group 2, and in group 1, I get treatment 1, and group 2, I get treatment 2. So you can see that I'm not blocking, I'm not doing anything else, and then of course I'm comparing results. And so this is a completely randomized design because each of the formula had randomly assigned to 10 squares. So in each one I had 10 squares, which was equal, and it doesn't always get exactly equal, but you want to get as close to equal as possible. This is the reason it's not matched pairs, because matched pairs would be like if I had a square, that's a rectangle, but one square, there we go. And I would say, okay, let's cut that in half and do one side here and the other side here, treatment 2. But it is not matched to pairs design, because I am not blocking them in size of 2. I'm not blocking them, in fact, at all. So this would not be block at all, because I'm just putting them, randomly assign them, group 1, group 2, where I have 10 here and 10 here. Okay, number 5. A dog company wishes to test a new high protein formula for puppy food to determine whether it promotes faster weight gain than the existing formula for the puppy food. Puppies participating in the experiment, so I'm looking to see if I can faster gain weight. Puppies participating in the experiment will be weighed at weaning. That's when they begin to eat puppy food, right after they quit, depending on their mom for nutrition. And then will be weighed at 1 month, intervals for 1 year. In designing this experiment, the investigators wish to reduce the variability due to the natural difference in puppy growth rates. Which of the following strategies is most appropriate for accomplishing this? So when it says most appropriate, there might be one that's good, but the answer is going to be the best one. So let's go for you see the good one, and then we'll go through the bad ones. But block on dog breed and randomly assign puppies to existing formula and new formula within the breed. And that's really great, because like if you see a German Shepherd versus like one of those little tiny dogs, that's going to definitely be, a German Shepherd puppy probably weighs more than some of those little tiny dogs when they're full grown. And so you're going to have definitely more weight gain and potentially even more percentage gain, potentially just because you don't know how it's going to affect them. So this is definitely the best one. But let me just kind of see this next one. Block on geographical location and randomly assign block on geographic location and randomly assign the puppies to a new formula within geographical area. Well, do you really think that a German Shepherd in Ohio is going to weigh differently than a German Shepherd in Texas? Maybe slightly, but that's not going to be the biggest difference. The breed's definitely going to be bigger. This is stratify. Cannot stratify. You see these, stratify. The reason the stratify is wrong is because, remember, stratify is for surveys, observational studies surveys, and blocking is for experiment. And you can remember when you're making your survey and you write the word block, you don't write the word stratify. Okay, number 6, measurements of water quality were taken from a river downstream, an abandoned chemical dump site. Concentrations of a certain chemical were obtained from 9 measurements taken from the surface of the water, 9 measurements taken from the mid-depth, and 9 from the taken of the water, the bottom of the water. What type of study was this? So I am just taking it, so it's not an experiment, so I'm going to kill the experiment once. A census would mean the entire water, which would not make any sense. So we know it's an observational study. The question now is it a concentration of the chemical or depth of the water? Well, the depth of water is just the different factors. The concentration of the chemical, that's the differences of the different things that I'm measuring, because I have measurements on here and I have 9, and then what type of the study and the response variable, because I am trying to see the concentration of the chemical were obtained, and that's the whole idea of the response variable, because that's what I'm measuring. I'm not measuring the depth of the water. The depth of the water are just the factors of my experiment. An agricultural study, scientist wants to compare the effect of the new fertilizer. We have X, Y, and we have Z on the growth of vegetables in small gardens. We have 200 seedlings, individually growth post, and randomly assigned. So randomly assigned is important to one of 4 groups of 50 each seedlings. are given a new fertilizer and the three mating groups an X, Y, and Z, respectively. At the end of 4 weeks, all seedlings are dried and weighed. The scientists found the mean weight in the seedlings of the group from the new fertilizer was significantly greater than the mean weights of the three groups. The scientists conclude, this is a conclusion, that the new fertilizer was more effective than other fertilizers for all vegetables. That's important. All vegetables, it says. Why was it not appropriate? Well, let's go back and see and remember and see what I did. I did 200 green bean seedlings. I did all green bean seedlings. So the first thing that's sticking out to me like a sore thumb is I did 200 green bean seedlings, and I'm concluding that the fertilizer is best for all vegetables, and that can't be right. So yes, indeed, it's the green beans and not to all vegetables. And these are not observational, so you could definitely cross those out. I'm just trying to see what the other ones are, but this is, and it didn't lack a control group as well, so definitely C. All right. A regional transportation authority is interested in estimating the mean number of minutes the working adults in a region spend commuting to work on a typical day. A random sample, that means we can conclude to a larger population of working adults, will be selected from 3 strata: urban, suburban, and rural. Select an individual that will be asked a number of minutes. Here's what we're asking: they spend time commuting. We're just asking. Why is stratification used in this situation? Obviously, because we know that urban, suburban, and rural are going to have a lot differences, and if we have them all smacked together, we're going to have a lot of difference in the time. Urban's going to probably have the very different because of the traffic. Suburban, if they commute into the city, and then rural, if they come way in, or if they just work locally and there's hardly any. So we're going to have such a difference of it. That's going to increase our variability. So we're going to decrease our variability by just comparing urban to urban, suburban to suburban, and rural to rural. And then that gets me, my results might be up here for this one, up here for this one, and up here for this one. But you can see all the results are going to be a smaller set, which is reducing variability, rather than having them all together. And then you have my results being all spread out, where this is like a number line, like 0, 1, 2. These are minutes commuting. So yes, E. Letter number 9, the researcher conducting a telephone survey is concerned about the possible source of bias. One of the following is the best example of non-response. Which of the following, excuse me. So the wording of the question, no, the non-response means there's no response. So no. The behavior of the interview, no. It has to be no response. People might be uncomfortable, no, because this is saying might do truthfully. It's many people selected to participate in the survey who do not respond. That's the thing, do not respond. And people without headphones are overlooked. No, not being overlooked, it's people that don't respond. Non-response is you don't respond. The buyer of an electronics store wants to estimate the proportion of defective wireless game controllers in a shipment of 5,000 controllers from the store's primary supplier. The shipment consists of, 200 boxes containing 25 controllers. Numbers from 1 to 200. Randomly select 6 numbers in the range and open 6 boxes corresponding numbers. Okay, what type of sample is this? This is a cluster because I have 200 boxes with 25 controllers, so every single box looks pretty much identical. Every single box has 25 controllers, so I'm literally just selecting one of them or two of them, or obviously, what they said, and I'm doing 6 boxes. I'm selecting 1, 2, 3, 4, 5, 6 boxes, and every single box, I'm selecting the whole thing. That's cluster. Finally, the last one here, we have researchers want to investigate whether babies have the sense of right and wrong. So they have 60 babies in a puppet show with red and trying to open a heavy box lid. The second puppy, called the helper, is trying to help the red puppet open the box, while the third puppet, called the hinderer, would try to slam the box down. After watching the show, each baby was presenting a tray containing the helper puppet, the hinderer puppet, and the researchers recorded which puppet would the baby reach for. The researchers wanted to determine whether the babies would reach for the helper or more in the hinderer puppet. As a part of the show, the green puppet and yellow puppet served as the helper and hinderer. For each baby, a coin was tossed to determine which color they would serve. So that's random assignment. Which of the following is the most important reason for random assignment? And I said, if the same role is played by the color puppet, the babies might show a preference of color. And that's absolutely right. Is that because we don't know, and so that's why we're randomly assigning them. All right, thank you very much.